Okay, welcome everyone to a real important lecture, and that's essentially a lecture on the concept of recovery. So, of course, all of you guys have heard of overreaching, or at least overtraining. Most people have not heard of overreaching. But I would argue that when most people are talking about overtraining, they're really talking about overreaching. So, if we think about this concept, um, what you have basically in the yellow box below is that how long it takes you to recover. Um, if it takes you days to recover, that's just normal recovery. If it takes you days to 2 weeks to recover, that's probably overreaching. And if it takes you months to recover, that's a concept that we call overtraining. So this is a sort of a depiction of it. Basically, what happens is that overreaching. So, in other words, overreaching is more short term overtraining. So, what we have in this concept is that if you're properly varying your training stimuli, then what essentially is going to happen is that you'll continue to make gains so long as the training stimulus is adequate to trigger an adaptive response. But if your training and recovery is less than the training stimulus itself, then you'll keep going down and down. If you can recover in days to a week to no more than 2 weeks, you overreach. If you're not recovered at that point, you're overtrained. So overtraining is a concept essentially that could take you months to recover from. This is why I argue that in all probability, most people don't overtrain. They overreach. So what are the symptoms? Well, when you're exercising, you perceive the exercise session as being harder. It's high perceived exertion. Your concentration is lower. You have decreased performance and severe fatigue, decreased appetite, things like overuse injuries. And I don't know about you guys, but when I'm overreached, I get pretty cranky. So, again, poor sleep quality and mood disturbances. So what causes overtraining? One thing is that like high intensity training is very important, but the thing is that if you do it too frequently, you could overreach, and that's kind of a concept. Um, so let's talk about this. Fry in this study essentially had people perform 10 sets of 1RM sets each day for 2 weeks on an overreaching cycle. And so again, 10 sets of 1RM for 2 weeks straight. But you notice that the people in the group that did the overtraining, they went down. And the control group stayed the same. So what we see in this is that if you look at the overtrained group, that their muscle damage was very, very high. Now, why am I not saying overreaching group? Well, it turns out that they followed these people like 5 weeks later, and a lot of them had not recovered their strength. So if you do like powerlifting training, and all you do is go heavy every single workout, and you have a high training frequency, that could be a problem. What it demonstrates is a need for periodization, that you need to vary your intensity and your actual volume in general. Another way that we can cause overtraining or overreaching is going to be high volume training. This is a classic study by Costal. And what Costal did was he doubled the training volume or the mileage swam in elite swimmers for 10 days. What I want you to notice is that their cortisol levels went up from day 0 to 5 to 11. And their performance did go down. So cortisol goes up, muscle damage goes up, things like this. So basically what the point is, there's a famous quote by the Greek philosopher Plato who said, "Know thyself." So research suggests that elite athletes are outstanding at monitoring their physiological states, while recreational athletes dissociate from them. So let's talk about pre-exercise. This is a scale that our lab's been using, and it's called the Perceived Recovery Status Scale. 0 means that you're very poorly recovered and extremely tired. Or 0 to 2. And basically what that means that you're going to expect, I'm going to have declines of performance. Right? If you're 4 to 6, probably similar performance. If you're 8 to 10, you can expect improved performance. So we use this scale in a study we published, and basically what you see is that if you look at the PRS scale, we had these individuals training a 40,000 pound bout. Their perceived recovery status went down from about 8.5 to under 4. And if you look at muscle damage as indicated by creatine kinase levels, it drastically went up. So as perceived recovery goes down, muscle damage generally goes up. We also see that there's a relationship between perceived recovery on the vertical axis and free testosterone levels. So basically, the higher your free testosterone levels, the greater the perceived recovery is. So that's very important. So what this says is that when you go into a training session, you should monitor your perceived recovery. Where are you at? Also, other monitoring tools are things like training willingness. How willing am I to train? That will go down with overreaching. If your appetite is poor, that goes down with overreaching. Your muscle soreness can go from no pain to severe. Your sleep quality is going to go down. And your number of hours slept, and your tiredness sensation is going to go up. So these are all things that we can monitor. So the question really becomes, is the only thing that we're concerned with that can cause overreaching or overtraining going to be physiological? In other words, it's going to be just your training. Is that it? Well, there's a thing called life, and it's not just your training. You can't just put an athlete in a bubble and say the only stimulus is their training, because it's not. Because we also have psychological stressors, and we also have social stressors. For example, you could be training hard, and if you have finals week, go into finals week, what's everyone doing? They're coughing, they're sneezing. Okay? Well, that is a psychological stressor. It's leading to overreaching because they're sick, which is one of the major signs of compromised immune function. You could also have a social stress. An athlete could be doing great, and all of a sudden their girlfriend or boyfriend breaks up with them. That social stressor is high enough to cause a decrement in performance and recovery. So now we need to talk about recovery theory. The recovery theory suggests that restoration occurs at 3 distinct phases. And that occurs basically within a workout, between workouts, and between training cycles. So within a workout, one of the things that essentially is going to occur during an exercise bout, that's going to determine when you can perform your next bout optimally, is inter-exercise rest. So it takes 30 seconds to replenish 70% of your ATP, but 3 to 5 minutes are required to fully replenish it. So, based on that, if you're going to do a heavy training day or train for power, you're probably going to replenish most of that ATP to do that, you're going to need to rest 3 to 5 minutes. But if you're training for conditioning, muscle, skeletal muscle hypertrophy, in that sense, you're going to rest lower because you want the lactate buildup. But your quality is going to be lower as far as the workout relative to intensity. The next one is recovery or restoration between training sessions. So truly, this is your initial performance, okay? And if you train, your performance goes down, okay? And one of the things is that the one factor theory suggests that a training session depletes the system or damages the system. So that's why performance goes down. But then the system supercompensates and gets better. But if you take too long to recover, if you take too long, then you detrain. You go back down to baseline. So time recover should be long enough to adapt, but not to detrain. So the one factor theory suggests, again, that a training stimulus leads to muscle damage or depletion of the substrate, which leads to supercompensation of that substrate, and that you should rest long enough to train again at that supercompensation time point, but not so long as a detrain. So, two of the major things that are going to affect how long it takes you to recover are going to be your, basically, one is if you don't have a lot of muscle damage, like if you were cycling, that's a high concentric bout, not eccentric. When you do a high concentric bout, you don't cause a lot of damage, but you deplete the muscle of glycogen. And as you notice here, after a training session, you deplete glycogen. With adequate carbohydrates, you replenish that in about a day. Okay? So basically what we think is that you should not be training in this window because you won't have full recovery. But if you had muscle damage, on the other hand, it's going to take longer than 24 hours. We can see that here. We're looking at soreness. If you train hard, soreness is going to go up and last at least 72 hours. Muscle damage is going to go up and last up to 72 hours. So if you do a hard, heavy training session where you have a lot of damage and soreness, you might need 48 to 72 hours. If it's just a lighter bout, like a power day, or a day that's more focused on concentric activity like cycling, then you might only need 24 hours. Now, sometimes when people hit a plateau, they do something called an overreaching cycle. So basically what happens is you have fatigue, you start to recover, say this is 24 hours later, and before you fully recover, you train again. Before you fully recover, you train again, and then you get an extraordinary supercompensation. Now, this is a very, very risky thing to do, and it's only for very advanced athletes. It's only for athletes who are extremely well conditioned and that they have low psychological and social stress. If that never happens, it's something that you should not try, and something you shouldn't have your athlete try. But if your whole life if a lot of your life is centered around athletes, and you're able to monitor social and psychological stress, you're able to get adequate sleep, and you're in a low time of school stress, this is one time that you could do this. Basically, what happens is you're going to increase your training volume, probably by like 50%. And you'll do so by manipulating frequency, most likely. So if you're training like 2 days a week each body part, you might train it 4 to 5. The last recovery theory is recovery between training cycles. So following a hard training season, or when you're getting ready to enter into the playoffs, an athlete will build up a tremendous amount of fatigue. The athlete will never know their true performance unless they taper. What the heck does that mean? Well, this is some research we did where we had a guy, this is his squat before he actually, this is before a study we put him in. He was squatting 325, and then after 10 weeks, or I think it was 8 weeks, we got his squat up to 405. So he had a 25% increase in performance. Now, why might he increase performance? Well, he definitely got some fitness gains. So one of the fitness gains that he got was his muscle quad thickness using the ultrasound went up. His quads went up, his strength went up. But is it only fitness that this athlete is dealing with? No, it's not just fitness. He's also getting gains in fatigue. And this is his fatigue at week 9. This is essentially the muscle damage threshold right here, and creatine kinase. Okay? And this is where he's at. So he has all that damage, but his performance is way up. What that means is that if we can maintain the muscle he gained, maintain the neural adaptations, and bring this back down below, then you would see his true performance. And that is what we use the taper for. And we'll talk about that in a second. So this is a fitness fatigue model by Bannister, and Bannister suggests that a training stimulus leads to 2 intervening variables that include fitness and fatigue, and essentially the difference between fitness and fatigue equals performance. With that athlete in our study, for example, his fitness gains outweighed the fatigue. But it's important to understand that if we could remove the fatigue and maintain the fitness, performance will go up ideally. And that's what you're looking to do, for example, before the playoffs or before a major event. So should we remove fatigue by completely resting, in the off season? Yeah, I'm just going to take a month off. Well, Mujaka and colleagues, and we actually also found that basically if you completely rest, you have 20% declines in endurance performance, 3 to 14% declines in muscle glycogen, 8 to 13% declines in one-arm performance. And this is short-term rest as little as, really, I've seen within 1 to 4 weeks. So bottom line, complete rest leads to detraining. This is where the taper comes into play. So Zaciorsi has a really good quote. He says, long breaks in training ruin physical fitness and athletic performance. Deadaptation inevitably takes place. Detraining occurs. After a prolonged period of inactivity, an athlete has to start from a decreased level of physical fitness. Time and effort are unnecessarily spent on recovering the pre-break level of fitness. As in mountaineering, if you want to scale the summit of a high mountain, why get halfway up the mountain, go back down, and then climb the whole mountain? The laws of physical training must be obeyed if one wants to be successful in sport. The need for continuous training is one such law. So this is where we come up with the taper, and I'm biased, but I think there's a really good paper on the taper that I published, but it was back when I was in my master's program, or PhD actually. So tapering is essentially a systematic, I should say it right here, tapering is a technique of systematically decreasing training load to facilitate a physiological fitness peak. The taper is a complex technique because load can be reduced through the manipulation of numerous variables, such as training intensity, volume, duration, and frequency. An extensive body of research has been dedicated to analyzing the optimal combination of these. So, if you taper, basically, you don't stop training, but you lower training volume in general. If you taper, you have 5 to 6% improvements in the criterion competition gains, up to 20% increases in power, 10 to 25% increases in muscle size, improvements in VO2 max, running economy, decreased muscle damage, increased testosterone, etc., etc. So let's talk about manipulating intensity. This is a study by Hickson and Shepley. And basically what happened is they had individuals and after long training, they lowered their training intensity by 20 to 40%, or they maintained their intensity. And notice that the low intensity group declined in performance. So never lower your intensity. It's like you'll see swimmers go, okay, just swim half intensity during your taper. That's not good. They're going to lose gain. So you need to maintain intensity. So what you lower is volume. If you have someone who has low fatigue, this graph is showing that their performance will be optimized at around 40% reduction in volume. So if you were bench pressing, for example, 10 sets, you'd go down to 6. Okay, but if you actually had trained and you had high fatigue, such as introducing an overreaching cycle, then notice that you would need to lower volume much more, like 60 to 70%. So what we think basically is that, and then the duration of the taper, if you have high fatigue, is probably going to need to be around 2 weeks. So for low fatigue, like, you've been training hard for the last month, but you want to peak for a 5K, then the taper should last 7 days with a 40% reduction in volume. If you have moderate fatigue, greater than 12 weeks of training, but no overreaching, and you feel pretty good on your PRS, the taper should last 10 to 14 days with a 50% reduction in volume. And for extreme fatigue, the taper should last 10 to 14 days and have a 60 to 70% reduction in volume. As far as frequency is concerned, this is a study where they took athletes, and basically what they did was they decreased their training frequency, and noticed that when you didn't lower frequency, performance was higher than when you lowered it. And we think it's because you lose your rhythm. So if you're training 5 days a week, you should keep training 5 days a week. As far as taper type, one group stepped off and basically reduced their training volume. Say you're ultimately going to reduce it to 50%. They reduced it by 50% on day one and maintained it. Or you do progressive, which would be like, for example, all over by 10%, 20, 30, 40, 50. Step was better. And it's probably because you're able to get rid of the fatigue because you have a greater overall reduction in volume. Okay, thank you.